All right, this is section 3.8, number 25, and the directions are find an equation for the tangent to the graph of y at the indicated point. So this was the function y equals inverse sine of x over 4. So it is a composite, so we have u equals 1/4 x, so du dx equals 1/4. We want to find it at x equals 3. So we'll go ahead first of all find the derivative. Probably have to use my calculator on this one to evaluate some of these numbers, but let's go ahead and find the derivative first. So again, the formula is going to be to find the slope at this point, we have to find the derivative and evaluate it at x equals 3. So the derivative is going to be 1 over the square root of 1 minus u squared times du dx. That's going to be the inverse sine formula. 1 over the square root of 1 minus u squared times du dx. And my u is going to be x over 4. So I just substitute this in the formula. It's my u squared. And I square it out. And what I want to do is, first of all, this is basically the derivative. Now, we've been doing some simplifying on some of the other problems. We don't have to because we're just going to evaluate this at 3 because that's at x equals 3 and we want to find the slope of the tangent line. Then we'll find the y value, then we'll have our point and our slope. All right? So I'll just put 3 in over here. And if I square 3, what I get 3/4, I get 9 over 16. So I'm going to try to combine these, so I'll make this 16 over 16. So, and I'll put the 4 in front. So I put the 4 in front. 1 is the same thing as 16 over 16 minus, and 4 squared is 9 over 16. And now the 16 minus 9 is 7, so I have 7 over 16, 1 over 4. All right. But what's the square root of 16? 4. So these cancel, so I just end up with 1 over the square root of 7. Okay, I could write this as the square root of 7 over the square root of 16. The square root of 16 is 4. 4 over 4 cancel. So skip the steps over there. Hope that doesn't throw you. But if you fill in the steps, you'll see that this definitely is this. Then I can rationalize, multiply the top and the bottom by the square root of 7, so I get the square root of 7 over 7. So that's my slope at x equals 3. What's my value of y at x equals 3? So I've got to put that back in the original equation. So if I put y of 3 in there, I get the inverse sine of 3 over 4. So I put that on my calculator and found the inverse sine of 3/4. And I end up with 0.848. Okay? So now I'm kind of stuck with these decimals. So I'll put this in. So this is my slope, square root of 7 over 7. And this is my point, 3 and 0.848. So that's my x and y. y1. Okay? And then we'll put this in the point slope form. Y minus y1 equals m times x minus x1. And you use your calculator to figure these things out. So this is my slope. That's my y value, my x value. So if we putting this in this formula here, we have this. And then I could just multiply the square root of 7 over 7 times x minus 3 times the square root of 7 over 7 when I multiply these. And then if I add this 0.848 to both sides, I'm almost done. Then the book had the answer in decimal, so I just changed this to a decimal, divided the square root of 7 by 7. And then I combine these. So this was negative 3 times this, so square root of 7 over 7 plus 0.848. We end up with negative 0.286. So that would be your equation of your tangent line to that function at x equals 3. So hope that makes a little bit of sense to you.